morning, everyone, and thank you again for joining us. I am so I attended a CTBUH event on that exact topic and with Michelle, which I will introduce in a moment, but it was so informative and kind of mind-blowing to that extent. And Michelle, I really need to give you the credit. It was an excellent night. And then I approached Michelle and I said, please, we need to make sure more people are listening to this. And Michelle said yes, so thank you for that, Michelle. And I'm very glad and honored to introduce Michelle Shurab, the Director of Innovation, BDP Quadrangle, who is going to speak about low carbon and TGS. I mean, we're going to cover a lot. So Michelle, please take it from here. Guys, type questions in the Q&A or in the chat, and I will make sure we get those answered. Michelle, the stage is yours.
Okay, good morning. Okay, so you can see what I'm going to talk about here. Naama's already mentioned it, so I will just get right into it. So we know, being in the building industry, that what we do accounts for a huge amount of global greenhouse gas emissions. So buildings account for 39% of global greenhouse gas emissions, and 11% of that actually comes from embodied emissions. So I'm going to park that for the moment. Looking at what the World Green Building Council thinks we should do about this. Their idea is that all new construction should be net zero operational carbon. So that's the carbon that it takes to run the building by 2030. And they also want to see a 40% reduction in embodied carbon, which is interesting because we haven't really been talking about embodied carbon until maybe the past 2 years, at least widely. And then by 2050, they want to see 100% of buildings, and that's new and existing, to be net zero operational carbon, which is just, wow, that's a lot. And they want 100% of new construction to be net zero embodied carbon. So that's a tall order. So let's just talk about this idea of a net zero carbon building and what that actually is. So a net zero carbon building it's a highly efficient building. And what you want to do is you want to produce renewable energy on site, or you want to purchase that, or you want to do a high quality carbon offset. And that's what's being permitted for the moment. And what you want to do is you want to make that equivalent to what it is you're using. And you want that to be both from your operational carbon to run the building and your embodied carbon. So just for a little sidebar, embodied carbon is the emission associated with the materials in the construction process. And I'll get into more detail about that. And operational is the emissions associated with running the building itself. So let's just look at that visually, since we're very visual people. So net zero emissions means taking your embodied carbon, which is from the materials that it takes to build the building and maintain it over its lifetime. You add that up with your operational carbon, which is the carbon that it takes to run the building. So the fuel, that's the carbon emissions from the fuel to run it. And then you subtract from that the avoided emissions. So this is your green power or any kind of carbon offsets. And the idea is that you net out to zero. Okay, so that's kind of the definition from the zero carbon standard from the CAGBC. Okay, so big picture, metrics to measure success in buildings are changing. So what we have seen is that changing codes and standards have really given municipalities, regulatory bodies, the confidence to go ahead and embrace higher levels of sustainability. So what we're starting to see is a push, kind of an upward cycle of increasing those mandatory requirements. And so that has been ongoing and will continue to be. The other thing that we've seen is some volatility in the utilities that we're paying, whether that's from global unrest, things like the war in Ukraine, or whether that's from trying to deal with climate change. We see tools like the carbon tax that have come into effect, which, the cost of carbon is set to increase by 340% by 2030. So that's pretty significant. So we're going to see big changes here. So all kinds of indicators pushing us in the right direction to take this seriously, even if the regulation isn't totally keeping up. And then you've got things like ESG reporting, which is really about investment. And so if you're in a REIT, if you're dealing with pension funds, this has all become a part of it. And it's something that has become tied to financial reporting. And the governing bodies, the global governing bodies, are working to align the reporting of environmental and social governance against financial. So this is very important. This is kind of a huge piece, a regulatory piece that's underway globally. There's been some pushback in the US, but it's really taking shape in Europe. Then we see things like this building in the UK, which part of why they said the project was rejected was because of its embodied carbon. And I thought that was really interesting, because what it's telling me is that even if there are minimal requirements or no requirements, it's becoming increasingly risky to ignore these things. So let's look at some of the response to that. You get things like green development standards. So after signing the Paris Agreement, you get municipalities who have been charged with reducing their emissions. And so when they look at it, this is something that came from the Atmospheric Fund when they did the carbon inventory of the Greater Toronto Hamilton area. And you can see here that red is business as usual and blue is where they want to go. So what the municipalities are working to do is to close that gap. And when in a city, like Toronto, where you have more buildings, the carbon impact is even higher. So what you get is a bunch of green development standards, and all of these municipalities have them. But the one that's been really leading the way is the Toronto standard, which was based on the zero emission building framework that was issued in 2017. And this was a pretty interesting piece in that they created almost like a steps for how we're going to get to net zero. And I'm going to talk us through that. So they created these absolute metrics and some other additional measures, and I'll walk it through. So we're in Toronto Green Standard version 4. So there have been 3 versions so far. So I know there's lots of confusion about the Toronto Green Standard. So it came out in 2018, we were subject to version 3, and there were 4 tiers. In May, we moved down to what was mandatory now drops off, and what was optional has now become the mandatory standard. So what you start to see is over the years, the lowest level starts to drop off, and you start to increase your requirements, so that by the time we get to 2030, the only requirement will be net zero buildings. And then they went a step further and they actually sped up the timeline. They said, okay, by the time we get to version 5, that's in 2025, and we want net zero by 2028. So what does that look like? So if you're working on a project right now, if the light gray and the dark blue are sort of pre-designed schematic design, if you're going in for your SPA application, which is what TGS is tied to, when you get to that, you may have already been working on the project for a couple of years. So it's really important to understand where these steps are going, so that something you're working on now, you can be planning ahead for where it's going. So let's look at some of these numbers, a whole bunch of gobbledygook up here, lots of acronyms because sustainability people love that. And you've got EUI, TEDI, and GHG, and I will get into what those are. So you've got these values. When we moved to tier 4, those values went down, meaning you have to use less energy, your envelope has to get better, and you have to reduce your greenhouse gas emissions. By the time you get to version 6, this is what those numbers look like. I'm not going to get into it now, but I will get into it. And I'll repeat those numbers again. So what about financial implications? There was a study done in 2017. This is fully about multi-unit residential buildings, and they'd said there was about they were comparing to the building code. Now we're at version 4. So basically they were saying this is what's required. And this is about 3.5% more than what it cost in 2017. This does not deal with escalation, just putting that out there. And the thought was that when they looked at it in 2017, getting from what is now version or tier 1, which is mandatory, to what is tier 3, which is voluntary, had less than a 1% difference in cost. So I find that very, very interesting, because what that tells me is where we're at right now, we should be exploring the design pathway to go all the way to tier 3 on every single project, regardless of whether you're going there. Exploring that pathway is really, really important to help people understand where it is we're going to end up. Now, the other piece that happens is development charges. So let's say we're looking at a 2-bedroom unit, you'd have to pay $55,000 in development charges. And then you would be, if you go for a higher level of performance, getting $4,000 or $5,000 back, depending on the version. And I'm going to jump quickly to say that if you were going for a tier 2 building with 200 units, that amounts to $829,000. So not insignificant. And if you were going to tier 3, which is the one that I'm recommending we explore, you're almost at $1 million in development charge refunds. So, money to be taken seriously. So what does that look like on a design timeline? You lock into your version of the Toronto Green Standard when you apply for site plan application. So that's the rates that you have to pay, your development charges. You pay those development charges when you go in for your permit, and then you receive your development charge refund back at the rates that are current at that time when you prove compliance to construction. So back to our 200 unit building, if you had submitted for SPA in May of 2018, you would be subject to your version 3 costs. So your development charge refund charges would be around $6 million, and you would receive your refund of close to $1 million in August of 2022. So not an insignificant percentage of the what you're paying already. So what's happening in the marketplace? This was taken about a year ago. We took a look at what was going on in Toronto. There were 323 cranes in the air, and of those, 90% of them were residential. Now, residential has been the slowest in terms of uptake in increasing environmental standards. Generally, what you see is in order to keep things equitable, people go for the minimum standards. So the question was who was going for, or how many projects were going for higher levels of performance? Again, this is sort of before the new version came out. We only found that there were 5 that were targeting. This was the stat that came from the City of Toronto. There were only 5 that were targeting a higher level of performance. And when we looked at, when we expanded that search to look at even higher performing projects, things like Passive House or the Zero Carbon Standard, we found only about 5. And when we looked at those ones were really in the affordable housing side or in the university market. So again, kind of interesting. Now, where I thought it was really interesting was New York City. This is where we're starting to see the first real wave of high-rise passive house towers. So these are a whole bunch where you can see that overwhelmingly the architecture is starting to change. Punched windows, no balconies. Since Hurricane Sandy, New York has been really advanced in very proactive in moving their environmental performance requirements ahead. And they've now put in this local law 97 that actually sets emission targets for buildings and requires that people report out and then pay the difference. So they're given a limit to how much they can use, and they have to pay a certain amount for every bit that they go above. So signs of things to come. So we put together a little think tank to have a discussion about how we were going to accelerate net zero with this group of companies, because there was a lot of frustration. Wow, why can't we make this happen faster? And we said, well, what if we put together something that said 3 steps that you can do on every project? So we put together this little study called Low Carbon Now, where basically the 8 companies got together, said, this is what I would do, this is what I would do. And we put together a short video and an infographic, which you're welcome to check out after. So one of the things was really about this piece, the importance of this decision-making process that happens right at the beginning, which is so challenging on these residential projects, given the sort of stop-start nature of these projects. But what we do know is that any decisions you make in this upfront planning process sets the carbon trajectory for the building for its lifetime. It sets off what it's going to be in embodied carbon, what it's going to be in operational carbon in the blue. And so what we're saying is try to make those decisions wisely at the beginning. The other thing that this graph demonstrates is kind of the time value of embodied carbon. Usually you talk about embodied carbon over the life cycle of a building. So if you looked at it over 60 years, it would maybe be sort of 40% of the total carbon of the building. But if you look at the fact that we're trying to reduce our emissions by 2030, if you look at it right up here, just that time loan, you can see that embodied carbon emissions are actually valued at about 85% of the emissions. So as we're building these buildings, they have a massive impact. So the 3 things that we said we should do for low carbon buildings: 1, build smarter structures; 2, prioritize the building enclosure; and 3, electrify your heating systems. We're going to get back to that. So let's talk a bit about embodied carbon. So embodied carbon really comes from the materials through their entire life cycle, through extraction, manufacturing, transportation, installation, and what you do with them at the end of life. So this is, you've probably seen these charts before. They can be quite confusing. People talk about A1 to A3 to A5, which is which. We did a range of studies that are really just about this sort of front end, which is really about the product and through construction, knowing that the majority of the embodied carbon impacts come in these first phases. So as I said, we've only been having this conversation really widely as an industry for maybe the last 2 years, and tons of literature has been published about it, which I find really interesting and kind of exciting, because we're realizing that embodied carbon is actually the elephant in the room. Probably the most advanced, in my opinion, has been the LEDI, which is put out by the City of London, the London Energy Transformation Initiative. This is an amazing guide. They've set benchmarks for all buildings in London and things to do, and are working on adjacent legislation. So one of the pieces, so build less, build light, build wise, build low carbon, and build for the future, and build collaboratively. So one of the things that happened here in the City of Toronto is we pulled together, there was a group of people that said, well, we need to look at what are benchmarks. We keep saying a 40% reduction in embodied carbon, but 40% of what? So Kelly Doran had done a studio for University of Toronto. One of our projects was part of it. We took the results of that, went to speak with the City of Toronto, along with Mantle Developments, and managed to secure some funding from the Atmospheric Fund for the City of Toronto to do a benchmarking study of buildings in Toronto. And what they found was, so they did a call out to many practices within the city to say, have you done any embodied carbon studies, any LCAs, and can you give us the results? And they took that and sort of benchmarked the median. Out of that, they provided this regulatory embodied emissions of buildings. So it's a policy primer for municipalities to talk about how they might go about regulating it. And what they did is they set caps. They said for 2024, we should have a cap of 500 kilos of CO2 equivalent per meter square. But not just that, but we want to reduce that number to 415 by 2026, then again by 2028, and then again by 2030. And what you're starting to see here is, here's the average right now, but really quickly bringing that number down. So we've been doing a whole bunch of embodied carbon studies within our own studio. Here are the results of 4 buildings. We've done more since then, and you can see that they sit kind of comfortably below that 500 number. But then you start to drop it by 2026, by 2028, by 2030, and you see how significant and how we're going to have to really start to rethink the way we're thinking about our buildings. Now, there are no mandatory requirements currently in the City of Toronto. I do expect that to change. At this point, this is really the recommendations in the policy primer. So how do we go about doing this? So we said, number 1, build smarter structures. So these are some of the results of projects that were done with the U of T study. There was a great article in the Canadian Architect about this, where they looked at where do the emissions sit. And this orange right here is the concrete, the blue is the steel. So if you look at that, the concrete, or sorry, the structure of the building takes really 75 to 85% of the embodied carbon. So it's really starting with the structural engineers. We worked with Intuitive Engineering, and they produced this. So we did a kind of a 40-story architect tower with 4 stories of underground parking, and said, where does that embodied carbon sit? The big chunk in the floor slabs and the transfers, another big chunk in the shear walls, and the other in special foundations. So we went through and did some optioneering and said, okay, well, if it mostly sits in the slabs, how could we create this differently? And so we looked at our 200 millimeter sort of standard reinforced slab, compared it to things that were achievable, like what they do out west. They have a reshoring technique that would allow them to bring that thickness down to 180 millimeters, which is a 5% reduction, or even looking at post-tension slabs. So this was one of our partners from Multiplex who'd done a lot of work in the UK where that's common, and that was a 10% reduction. And so we said, well, easily right now, we would stick with what's here, but hopefully eventually we can move to these higher levels about thinking about it. Lateral systems in these buildings, we tend to do shear walls. If we move to something like wallums or discrete columns, you can then move to a 6.2% reduction. Again, pretty significant and very possible in our forming techniques now. The other big spot where we found embodied carbon is really sitting below grade. And a lot of this has to do with where the water table sits. So if this is our Archetype project, about 28% of our embodied carbon emissions were sitting in the underground. So it stood to reason that we would look at what would it take to go from 4, 3, 2, 1 down to no parking below grade. What was really interesting here was the fact that the difference between one level of underground and none was only 1%, but we could achieve really significant savings of 11% by going down to just 1 story. And then from there, now we've reduced the volumes of our material. The next thing is to look at the materials themselves. So we looked at different kinds of cement and different kinds of rebar and came up with a further embodied carbon saving to get the structural number down to 200. So it's another 34%. And this will all come in the procurement side. So pretty important. And then of course, there's the shift to mass timber. So looking at that, this is another possibility. If you're looking at a cross-laminated timber floor assembly, including the layers that you have to put on for fireproofing, it's still a quarter of the embodied carbon per square meter compared to a concrete floor assembly. So quite significant. And given that the Ontario Building Code changed in July of 22 to allow us to do encapsulated mass timber, I trust we're going to see a lot more of these coming in the next couple of years. So on the structural side, really having these conversations early, simplifying that structure, minimizing or eliminating transfer structure, minimizing your underground really is extremely important. Prioritizing columns or wallums over shear walls, and then low carbon materials. On the operational side, talking about enclosure, a couple of key pieces. So I showed you those numbers at the beginning, this EUI, TEDI, GHGI. I'm just going to tell you a little bit about how those work. So energy use intensity is the total amount of energy that your building uses. And so it's really about reducing that demand. So what are you using that energy for? Then you've got the TEDI, which is about your thermal energy demand. So that's about your heating. And so what are you heating? The strategy for that is really around optimizing your enclosure. So lowering that window to wall ratio, really simplifying your glazing so you don't have as much thermal bridging at your mullions, simplifying your form, making it as compact as possible, and doing a high quality rain screen cladding, prioritizing moving that insulation to the outside. And then of course, in multi-unit residential, the other part of the enclosure is the balcony. So really reducing the amount, thermally breaking them if you are providing them, or eliminating them altogether. And then it also has to do with your with heat recovery and your ventilation. So those are the numbers, the big things that affect the TEDI. And then in terms of greenhouse gas, it's really all about fuel switching to electrification. So you bring that TEDI down by doing an enclosure first strategy that reduces your load for your EUI, and that in turn starts to make your electrification make more sense. We did have a project where we did air infiltration testing on 80 Atlantic, and this is another piece that you're going to see coming up really quickly on these kinds of buildings, especially as we move into passive house, super insulated walls, and all kinds of high performance, large format, high performance wall systems. So looking at ways to replace the way that we're building now, or these glide on thermally broken balconies. And so on a project that we were looking at with a bunch of different partners, the contractor had put together this crazy spreadsheet where we were looking at the system itself, the assembly, the performance, aesthetics, cost, schedule, constructability, and carbon, and really comparing all of these things together to make really wise decisions. We took what they were doing, looked at all of those high performance assemblies, and looked at the embodied carbon per square meter of each of those high performance assemblies. And you can see this, if you go to low carbon now, there is this study that you can pull and look at in a bit more detail. I know I'm going quite quickly here. So here what we've done is we've taken these high performance systems. On the left-hand side, we have their effective RSI value. So you can see, other than this one here, they're all pretty similar in terms of thermal performance. But then on the right side, we have the global warming potential, or the embodied carbon. You can see that they're not all created equally. So looking at high performance curtain wall, it's a very high ratio because the embodied carbon of the material is so high compared to this architectural precast panel. So on the envelope side, understanding the carbon properties of the materials, really using aluminum judiciously because it's the aluminum that pushes those numbers up. maximizing your stud spacing, specifying low carbon insulation, and really considering that ratio between the global warming potential and the RSI. And again, tons of material out there. City of Nelson put this out, another one that was put out by Hines, another one called Kaleidoscope. So many pieces, and this is the BDP quadrangle one. And then moving to electrification of systems, which I'm just going to keep it brief and skip past that. So going forward, we're used to talking about time, quality, and cost. This we thought was great, where they added one more metric to this, which is carbon, that we have to be thinking about carbon at the same time as we're making these decisions about time, quality, and cost. So really, in terms of your decision tree, so much of it is generated from the design itself. So reducing your underground, reducing transfers and step backs, keeping that window to wall ratio nice and low, and your ratio of the vertical to the horizontal. From there, moving to innovation, mass timber, 2D, 3D modular, clip-on balconies. Usually those things cost a little bit of money. So the question is, does it create other benefits for the project? Does it de-risk other things? And if yes, go for it, invest in those things. If not, then you need to start to think about procurement, procuring those low carbon materials, especially for the concrete, steel, and aluminum. So final takeaways, really, to get to high performance solutions, you can't simply take an additive approach to the way we've been doing things. We really have to be judicious in our thinking, rethink our assumptions about design and technical systems and the processes we follow, because it's not all regulated yet, but we know where the market's taking us. We have to be questioning that business as usual, and even if it's not regulated, and engaging technical subject matter experts or contractors, consultants early in those integrated discussions, and trying one new thing on every project. Using embodied carbon tools, there are so many of them, to measure the performance as you're designing. And finally, that investigation of what it takes to get all the way to net zero, and chart that path, even if you're not going to use all of them in this project immediately, but charting that path. And I would encourage you to go check out Low Carbon Now if you want to see a little bit more of this. Thank you.
Thank you very much. I was typing and addressing some of the questions that I know already. And also for those of you who asked me about the deck and copy. So this presentation is also broadcasted to our YouTube channel, so you could access and watch it again any given time. Michelle, another question was about Bill 23 and how it will affect these standards.
Sorry, what was the question?
Bill 23.
Bill 23. Well, from my understanding of what happened within Bill 23, so there was a statement put out by the Atmospheric Fund that said the language was shifted to allow municipalities to keep their language in. So my understanding, City of Toronto and the municipalities are moving forward as if nothing has changed. So some of the language that was originally taken out was put back in. And again, the statement from the Atmospheric Fund was that nothing would change. And so that's the response that I'm going with on that. We're behaving that way as well.
Another question, and that was also a very lively debate, even after the event I attended, when we met, it's the question about balconies. And in Toronto, we have this very emotional discussion that against condos, where should people live, houses versus tall buildings and mid-rise buildings. And then you're basically saying balconies are bad. We need to stay away from that. What would you say to the sales teams, the architect, the developer? How do you even start to making a shift in that, under that topic of balconies?
Yeah, I mean, the topic of balconies is huge, and I would never say that balconies are bad because people get a certain amount out of them. What I do notice is they don't get used an awful lot, but there's the qualities of balconies that you still want to maintain. There's a quality of life, that there's understanding that you could step outside if you needed to. There's something about having that access to fresh air, or that place to put stuff, or a place to sit. Interestingly, a lot of people that I surveyed use it for their guests to smoke because they're in non-smoking buildings. They don't want to go all the way downstairs. So we've done some exploration internally and are still working on something that you're going to see come out in the next couple of months, where we're looking at what are the qualities of balconies and what are those qualities that we want to capture, and is there another way to inform the design, to bring up that design quality, still provide those qualities of life, but in a different way. And so can stay tuned for what that ends up being. But I do think that it's not just that space to stand, it's also about the size of the opening. It's about the threshold. It's about being able to sort of lean over a little bit. I think there's multiple things about it that really work. There's also things that you've seen that are, much more commonly adopted in Europe, things like the sunroom, the winter garden, those sorts of pieces, and shared outdoor spaces, which we don't tend to take advantage of, or we do them as one large space rather than, what would happen if you thought about them more as, on a floor by floor basis, or a couple of them together. So I think there's multiple ways of envisioning it. What I'd like to stop is the balcony as a default, but stopping and thinking about the design impacts and design first. What are the qualities? What is the quality of life we're trying to get out of the balcony? And can we replicate that in another more creative way where you still get those things, and maybe not just get those things, but get something better out of it? That would be, as a designer, that's really what you want.
Yeah, to be honest, maybe we're just one family, but we live in a condo and we use the terrace with the shared amenities and the barbecue every weekend in the summer. But I don't remember when we really, spend time in the balcony. Also, when you have kids, it's like so scary to have a balcony that you just keep the door closed all the time. More questions. Sorry. Do you envision a shift in the ownership and development structure, investment, collective development of mid to high-rise buildings to prioritize this lifestyle investment that aren't in the best interest of for-profit condo development, but have long-term payback opportunities for building occupants/owners? So basically buildings that won't be developed by the typical developer.
Yeah, I mean, I don't have a background in finance and to that side of it. So, what I'd say is I'd love to see more stuff that is designed, that is community-based design. We don't see a lot of that. My mom lived in a co-op for a number of years, and the way that functioned was so much more interesting, but I wasn't around for when it was built. You do see when you do get people that are organized with a certain vision, working in that direction, that they're able to realize something different. If you move to something like a passive house standard, I find it really, really interesting because they're talking about operational energy savings of like 90%, which is just so far beyond what we've tried to do, that you start to think, well, it really only makes sense if you're going to live there and reap the benefits of that. And so maybe it's also the savings in the utility structure. There's many ways to be thinking about the business model for this. I'm probably not the right person to ask about them. But we have seen a shift even in things like providing geothermal for buildings. So you get companies that are out there they pay the capital costs for the geothermal, and that's an electric heating system. If they're paying that cost, you're removing equipment from the roof, which means you now are missing that equipment on the top, which means you could put a unit up there, or you could put your amenity space up there. I do think it's about not adding on to what we're doing, but thinking about what we're doing slightly differently to get to these higher outcome results. And it's absolutely true that in terms of condo development, where the person who is developing the building does not reap the benefits, it's a much harder argument, which is why things like those development charges are so significant. But even then, speaking to some developers, it's very challenging. So unless the regulatory requirements move up so that it's an even playing field for everyone, you won't see it become the norm. But some of the suggestions that we're putting out there, things like the structural system and really looking at those pieces, are things that we can be doing regardless. And so I think some of the steps we do need to start taking now. So electrifying by doing things like geothermal, looking at the embodied carbon of the structure. So not sure if I exactly answered the question, but that's where my mind went with it. So
it's an interesting, it's a very interesting question. Last question before we wrap up. How would you like the manufacturer community to contribute? So basically, your cross-functional team, for example, included local consultants and developers, but not global manufacturers. What should those who represent the largest global firms do?
Sorry, so the question was about including manufacturers in the discussion?
I think, yeah, and then there was a clarification that Blair, it's a question from Blair saying that they want to be part of the positive change. What bigger firms could do to take part in this change?
And by bigger firms, you mean bigger manufacturing companies? Is that...
According to the question, yes.
Okay. I think helping us with the business case is a really big part of it, and really being able to demonstrate the technical proficiency. And so each of those things, so that master spreadsheet that was created by the contractor for that was actually for a real project. You know, one of the things in that was being able to quickly tell us about the cost implications, the constructability, how does it affect the other trades, really understanding the impacts, because so much of that savings, if we can get that savings, so you look at something like the underground parking, going down 4 stories and then coming back up, you know, that takes a year of construction time, a year longer that you're borrowing the money to put into this building. So if there's ways that you can shorten the construction time, that's a way to save money. But I think in terms of a manufacturer, being able to share that information with us very quickly, work on the business case, really model alongside us would be incredibly helpful. Helping us to understand the supply chain and procurement and whether we need to be doing things. So when you're moving to things like 2D modular or any of these kind of, you know, having done a mass timber building, knowing that we move to a design assist very early in the process to work with the manufacturer on the project. So that they were doing working drawings and detailing in parallel to us. And so it is those sorts of shifts in thinking about where the manufacturer should come in. The complication on these residential buildings, again, has to do with the stop-start nature of the projects, where you work to rezoning, then you stop, and then you work to SPA, and then you stop, and then you sell the building, and then there's a big gap, and then you start again. So that part can get tricky, but ideally you are bringing those manufacturer conversations up early as well. So hope that answered the question.
Process. Okay.
Yeah.
Michelle, thank you very much. Thank you. The numbers were very high. Still, no one left. That's a very, very good compliment, Michelle. It just speaks to how informative and interesting your webinar was. Thank you very much, everyone.